Hi, my name is Surah Ar-Rahman binti Muhammad Sufyan.
Hi, my name is Zainurisa binti Teddy.
Hello, my name is Siti Sarah binti Ahmad Lufi.
Hello, my name is Muhammad Harid bin Arifin.
Today, we will explain one of the fundamental concepts in physics, which is moment of a force. Moment is a measure of its tendency to cause a body to rotate about a specific point of axis. It describes the turning effect produced when a force is applied at the distance from a pivot. When wind blows onto the blades of a windmill, it creates a turning effect that makes the blades to rotate around a pivot. So, in this video, we will explain further about how does this concept is applied and how does it produce.
The center of the windmill is the pivot, while the blades are rigid body that rotates when the wind pushes them. The force from the wind acts at a distance from the pivot, creating a moment that turns the blade. As you can see, we have prepared two windmills of different blade lengths. From what we have observed, we found out that the longer the blade is, the greater the moment produced. This is because the longer blades increases the distance from the pivot, resulting in larger moments.
The basic torque equation is torque equals to radius multiplied by force. But for windmill, the force is the wind's momentum change. So we can link this in the equation of power equals to torque multiplied by angular velocity, which is the wind's momentum change. We can also derive the power of wind by using the kinetic energy, that is E equals to 1/2 mv squared. But the air has density, so we need to use m as in mass flow rate. Mass flow rate is equals to air density multiplied by cross-sectional area and multiplied by speed. So we take this and substitute it into the kinetic energy, and we will get power equals to 1/2 multiplied by air density multiplied by cross-sectional area and multiplied by velocity cubic. To prove the moment theory, I will do the calculations based on real-life examples. Let's say that windmill A has 20 meters radii and 1,257 meters square swept area. The wind power will be 1.33 megawatts, and the revolution per minute will be 43. The torque experienced by this turbine would be 175,111 Newton meters. On the other hand, turbine B has 30 meter radii and 2,827 meter square swept area. The wind power would be 2.99 megawatts and the revolution per minute would be 28.9. Hence, the torque experience is 591,000 Newton meter. This is 3.375 times more torque than the turbine A. Each turbine naturally reaches an equilibrium speed, where the driving torque from the wind balances the resisting torque from the generator. Due to the different blade lengths, the turbine settles at different rotational speed, different RPM. The longer blades spun slower but produce significantly more torque. In this case, it is turbine B. On the other hand, turbine A spun much faster but produces little torque, despite facing the identical wind condition. Proves the theory of moment, that is, longer blades make a lot more torque because of the increased distance between the pivot.
Torque is a execution force that makes rotation possible. In the wind turbine, wind pushes the blade, generating torque that spins the shaft and drives the generator to produce electricity. The power produced is the product of torque and rotational speed. Engineers control torque by adjusting blade angle or using brake to maintain efficiency and prevent damage. Just like the Quran described wind as a purposeful and measured torque channel that energy in a controlled, balanced way, transforming neutral motion into usable power while reflecting the precision embedded in operation. Allah says in Surah Ar-Rum, verse 48, "It is Allah who sent the winds, and they stay the cloud, and He spread them in the sky as He will." This shows that wind is not random. It is a force created by Allah, moving with purpose and effect. Just as the wind can cloud to bring rain or sail to move ship, it also can template into turbine. The Quran emphasizes balance in creation in Surah Ar-Rahman, verse 7 and 9. Characterize the heaven and establish balance, so that you do not transgress within the balance. This principle of balance and measure apply to torque. Every force, rotation, and movement follow precise rule, reflecting divine order.